Hello. I'm an AI human created. You're listening to Hannah's presentation for Dream Studio. The project is called Data Garden.
Humans' appetite for creating data is insatiable. Data experts agree that the amount of generated data will be growing exponentially in the future. In the following, cloud infrastructure is growing and consuming huge amounts of electricity. The combined environmental impact of all these data centers has been an increasing source of concern. The question is, how does big data store in the future? The idea is Web3 to Web3. It is a new type of data infrastructure that promotes unification between people, ecosystem, and technology. The project features plants encoded with data. Since the most important data during history is art, using the technology to preserve human heritage for future generations is the main subject of this project. Working with nature to alleviate the threat of museum fatigue, the Data Garden invites visitors to experience new materiality around data and explore a world in which the museum is truly green and exists as an accessible public resource that is shareable within communities in a kind of data storage typology. The site is located in the southwest of London. It is based in the Kew Royal Botanical Garden, which is an internationally important botanical research and education institute. The Jodrell Laboratory building represents roughly 60,000 samples in the DNA and tissue bank. Around 7 million preserved specimens of vascular plants are kept in the herbarium. Over the 170 years, a wealth of information on plants has been gathered and preserved in these specimens. The Millennium Seed Bank, which is the world's largest underground seed bank and conservation resource for diverse wild plant species, is in the partnership with the Kew Garden. Kew Garden has a solid architecture history. Each generation follows specific paradigm in architecture. The timeline starts with the Gothic in 1631 with cupolas, continues with the first large-scale structural use of wrought iron in Palm House and Temperate House, and ends with the Alpine House in 2006 with modern contemporary architecture. The question is, what would be the next architectural greenhouse design in this garden? My experiment and exploration in AI had 3 steps. The output of each step was filtered through iterated exploration and advanced prompting phases. The first step was text to image, to enhance the inspiration for the biomimicry organic greenhouse architecture and the composition of the site, how the inner spaces connect with each other by their structure, and how the architecture sits in the site were the questions that I followed during this process. Next one is the process of forming the concept of the project. It is image-to-image experience started with the plant seed and ends with the Voronoi structured greenhouse. Then to have the fictional aesthetic, 3 images combined together to help me closer to what was intended for the interior spaces and have a fictional perspective of my design. It continues with the image recycling. Remixing the previous outputs give me the final result of the interior spaces, which was the combination of my design and the fictional touch of AI. AI helped me to shape my design in 4 different parts. First, aesthetic fiction, used to dream things that normally would not be part of our daily life. The second one is the sense and color. Giving a sense of belonging to the space was the aim in this part. Forms. Understanding the shape and structure of these images were learned by testing, modeling, and analyzing it. To prepare the site plan and the connection of the different parts of the project, analyzing the composition of the site was inspiring. The design was developed within three main parts: site, form, and structure. The party diagram illustrates the creation of the data garden in the site. There are two buildings in the east side of the site which are abandoned and are part of the destruction agenda for the development of green spaces. Regarding the site entrances, main spots are placed in the site, gathering and connecting the related inner spaces according to the location of the trees, and the circulation of the site were the next step to enhance the final site plan. Following this, the process of creating the form including considering the sun path, the position of the trees on the site, and the connection between the interior spaces. To respect to the design paradigm, which is biomimicry in architecture, the organic fluid form was the aim of this process. The final shape is the result of connecting the facing side of the spheres and moving the bridges to guide sunlight to the main greenhouse spaces. The last and the most significant feature of the design process is the structure, which is the most important architectural aspects in the greenhouse design. This structure is common in all kinds of traditional greenhouse building. To commit to the biomimicry design paradigm, finding an answer in the nature was the first step. The many manifestations in natural organisms provide a rich sourcebook of ideas for structures that could be radically more efficient than those found in conventional architecture. Seed is the beginning and end of the life cycle of plants, carriers of the genetic codes that will ensure successful propagation and continuation of the species. Therefore, it is an inspiration for the beginning of the data garden design for saving human cultural heritage. In addition, the single-layered seed code has a distinct Voronoi pattern. This pattern ensures maximum stability for the structure with minimum thickness and weight for its load-carrying parts. The Voronoi diagram is the mathematical exploration for a visual pattern often found in nature. The Voronoi diagram and its numerous generalizations for the division of space are a source for the design of spatial structures. The following diagram illustrates the order and mathematical aspects of seed geometry. Finding logic behind the irregularity is the output of extracting the hexagonal cellular structure of the seed and analyzing it. The creation of the outer structure of the data garden is the result of Voronoi pattern application. Points were given by the grasshopper calculation area to create the Delaunay triangulation. Then the Voronoi diagrams appears on each surface of the design models. The isonometric 3D view of the data garden represents the structural principles in the form of organic and fluid architecture. The south elevation. This view and its skyline remind the hierarchy of the palm house shape, one high core in the middle with the two lower sides. There are two separated buildings in the site. The one in the east side is for public use and the opposite side is for researchers. The journey starts with the Wonder of Nature gallery displaying paintings and art. It continues with Library of Life where people can read books in the silent space. At the end, there is a converted lab for the public use and a cafe. On the other side, researchers have their own laboratory connected to the research greenhouse. Also, there is a seed bank in the main greenhouse. On the left, there is a Library of Life, and the right side is a Wonder of Nature gallery. Each kind of tree represents a paintings of a specific painter.